Okay. Hi team. Good afternoon. So today I have developed this movie ticket booking system, where we basically more focus on all the requirements that given within the projects, be it ticket, be it search features, be it ticket booking thing. Okay. So all the features I try to implement it, and apart from that, I try to keep the what we call um backup thing also. Let's say we are in this project right now. I am using the this Redis for this thing, distributor locking, but I have kept this SQL also for the, let's say Redis is whole cluster is down. In that case I can use that SQL thing. Okay, first of all, let me rerun all the test cases that I have written here for all the things, be it infra, be it this thing booking thing, all the tests I have written here. So let me rerun it. uh, yeah, so here I am rerunning it. So around 71 test cases were there, 11 got past 72. Okay, and let's see, all of them, most of them, all of them will passed. Yeah. Okay, okay. Yes, all 71 of them got pass. These things. These are the Kafka messages that getting generated multiple times as I have used the Apache Kafka. Okay. Okay. In case of one second. Yeah. So for double seat guaranteed, I have used like it should never be, because of for that I have used this Redis, and here basically whatever the operations Redis does, it does atomically at a particular time. Let's say more than one thread is coming, so it will not, it will execute the instruction one by one. So let's say first person came and they have saved the data within the Redis, the for that particular seat. So the new one, new user cannot, like next user cannot do the same thing. I'll show within the HLD also. So this was the proof that my program is working fine. I have written all the requests, all the required DTOs. Apart from that, the admin control. Let's say admin wanted to do the add the movie, add the theater, create the movies screen, etc. Okay, authentication layers I have written, register and login. Apart from that, the this booking control I have kept, where the hot seat, hold, confirmations, cancellations, get booking, list of bookings that I have did. Okay, apart from that, the browse control I have did, so list of cities, like a list of source, get source, etc. Okay, these are the exception class where I have saved the exceptions. Okay, apart from that, the other infra thing is there, where we have used the like Redis for the persistence. There is a Postgres DB that I have used. Okay, now let's come one by one. So this is the project which I have shared. Okay, GitHub I have uploaded and keep it public. Now let me give the uh, one of the information that required. Okay, let me go. Okay, on HLD part. So from web or mobile they can connect with our applications, the Spring Boot applications. In this case only one of the instance is running, that's why on 8080 I have put in one of my instance. We can, as per the scale, we can keep it as many based on the CPU and memory uses, we can keep as many instances we want for our applications. Okay, okay, firstly we do the JWT token validations. After that we come to the controller, and from here the multiple, as I've shown you, multiple APIs are there. Based on the use cases we select whichever the APIs are we wanted to use. Then those API basically calls this service layer, and service layer basically call all the infra thing. Let's say one of the use cases that I can talk about, the booking service. Here whenever the user say atomic hold, confirm or release. Okay, so in this case Uh, okay, so basically, whenever we wanted to hold a particular seat or confirm a particular seat or maybe release that particular seat, this all information will be atomic in nature. Okay. Next, how we are managing this holding of sheet or by releasing that. So we have the three options that I have chosen. For if we have the single instance only, in that case we can go ahead and utilize the in memory within that instance only and keep the number of seats within the hash map. I am assuring that that is for in memory only and just for the demo purpose. It will not work in the production also, since let's say restarted. In that case, if someone have hold the lock on within that hash map, it will also go, it will go away, right? So that will show the false impression. That's why I don't uh, feel the in memory hash map is a good solution or cache. Okay, the better solution is I have the two better solution. One of them is the best one, and then fallback I have. So we can use the Redis here. Why Redis? Why not some other software? Okay, like in for the cache there are multiple caches are involved. Firstly, the let's say Redis is there, Caffeine Cache is there, Aerospike is there. In Mintra, we are extensively using the Aerospike. Okay, so Caffeine Cache is only for the in memory. Redis is apart from the Aerospike. Why haven't I chosen the Aerospike? The reason for that was we don't have that much like very less information we are putting within the Redis. If we are putting a lot of information, in that case we can put it within the Aerospike. Basically Aerospike, how in that way, if you we are using the Aerospike, in that case the whole storing data within the Redis will be within the Aerospike will be too less. Okay, that's since the key they store within the red in memory and the value they store within the real hard drive, and from there like SSD, and from there they just get the address starting address of that particular thing and some more metadata and just store it within the as a value. So whenever you want lookup, you firstly find the key and corresponding the hard drive values and hard drive address, and then go that particular hard drive and then read it. So it's more kind of sequential read, or the time complexity is still the same almost in O of like let's say less than 10 milliseconds or 1 milliseconds, both of them got answers. Okay, let me go ahead. And whenever there will be let's say we are writing in Kafka as well as this thing DB, let's say we are facing the issue key the DB is working, we got the DB, but Kafka is not getting updated because of some failures. In that case, we have used the odd box pattern for that. So firstly, once write the DB, let's suppose Postgre one, then another DB also we can write, and after that we can use the cron job, and which will basically pick one of the element, all the Kafka events from the oddbox DB, and put it within the consumers, which guarantee that always the Kafka event got generated. Okay, for the Kafka event, we have used a Kafka event for multiple purposes: send reminder, send notification. Notification can be in multiple types. It can be of what we call email, phone, SMS, app notifications. These can be okay. So for multiple purposes, we are using the Kafka consumers. Why not RabbitMQ? Since in case of RabbitMQ, for here how Kafka we are managing this, we have built consumer groups. Okay, so multiple consumer group is doing one of the stuffs. Like for notification, email notification, we have built one of the consumer group. For audit, we have built another. For reminder, we have built another consumer group. In that way we are working out. Okay, but in case of RabbitMQ, we have to build a different queues, because of which it will be more expensive. Apart from that, the output that we are looking for, 1 million users are striking my system, so that RabbitMQ also will not be able to, like, it will be able to scale, but that infra cost will be too high and complex system also. So that's why we want the Kafka here. This is the how my system is at the local it is. So 8080 I have deployed everything, and then at 8080 my code is running on this port. 5432 is my Postgres is running, Redis is running at this one, Kafka is running at 9092, and Zookeeper is running at this one. Okay, 20 some value is there. Okay, now let's come down to this thing. We have the three layer. First is the REST controller one, orchestration layer, and then the or where we write the business logic also, and then the real infra layer. Okay, this is the thing that I've shown. So firstly, the time is already up, but still I'll show one of them, and then I'll go directly with the next one. Okay, so firstly we check. We whenever hit the source. Okay, after that the you wanted to hold that particular seat, so you call the hold API, and then it goes to the this booking service, and from booking service it hits the this Redis to hold the seat. After once, if no one have hold, in that case they will just return, and then we will update the Postgre, that is the persistent thing. Once the payment and everything confirm, then we update the Postgres, and after that committing, we will just come back and say the user, though your seat is confirmed, is the payment got confirmed in that case. Okay, now in case of rejection, let's say we call for the hold, we already have seat one as holded, so we have rejected that one. So this is the payment confirmation one. Here the numbers is there, but I feel there is some issue with the lines, because of which we are not able to see that. But we see the payment confirmation, and then only we go for the seat booking and all. Okay, this is the life cycle of the seat holds. Firstly, we say we confirm, we can cancel it. After that, if TTL reached, we can just it will expire, and if payment got declined, in that case it will just failed. Okay, these many tables I would like to keep entities. So movie will be the first, then so, then booking, then discount, and these many tables will be since time is up, so I am going little bit faster. Okay, so these are the tables, catalogs, classes. Uh, Basically these will be the relationship that I wanted to keep. Okay, yeah, these are the tables and relationship, oddbox tables or event we kept it. Yeah, this much. These are the SQL query that I have used here, and apart from that, some of the more SQL queries I have written here. Okay, for different use cases. Okay, yeah, this much mainly. Apart from that, let me go. You can deploy, and you can run it and run and put the admin or consumer password, and accordingly you can play with the software also. Then let me go with the AI uses. I have used the AI extensively to complete this project, since it was time taking. That's why. Okay, so for different for AI, I have divided into two parts. Firstly, the implement planning phase. This, as they are saying, where extensively I have planned my software by dividing the chunkings. Not exactly complete planning. So firstly, we have first part, like let's search features we want, to search features only. Booking feature we want, to just we want the planning of booking features only. Later on, I completed within the single thing. Okay, so like DB backup we want, so we haven't said in a first case only ki give me the DB backup. So in that, if I have given that, it will be really confusing. That's why I haven't given that. So this planning I usually do it with the little bit expensive models, and then the since we have the detailed planning in multiple phases, so I am able to understand the planning also. So that's why I put in. After that, I got the plan.md file. After I'll move it in the next phase, that will be the implementation one. So here the implementation task, I'll do it with the lower cost LLMs or models, since we already have the detailed planning. That's why we can use it. Yeah, for now this much. Yeah, it's and time is already up. Yeah. Uh, yes. So yeah, thanks team to listening this, and overall thank you.